Alright, hello again. So we're still on subsection 4, linear functions, and part 4 is where we're at now. So these are parallel and perpendicular lines. Recall that for two lines to be parallel, their slopes have to be the same. The natural thing you should imagine with parallel lines is train tracks. Because train tracks have to be the same distance the whole way along, because if they aren't, then that's going to be very bad for the train. Okay, perpendicular, of course. Okay, intersect at right angles. Okay, and for those to happen, the slopes have to be negative reciprocal. So something like 1/2 would be perpendicular to negative 2 over 1, or just negative 2. So that's the idea there. I kind of stole my own thunder with example 1 here, because what is the slope of the line segment perpendicular to the segment of that? Okay, well, you flip the fraction over, so it's 7 over 3, and then change that sign. So it was negative, so now it's positive. So the slope is just positive 7 over 3, or just 7 over 3. That's pretty straightforward. All right, so number 2. Find the slope of the equation of the line through the point that, and it's parallel to that. Sorry, the point slope. Okay, so we got to do point slope. Got to remember what that is. That's way back from part 1. Anyways, look at this. So this equation here has a slope of 1/2. So, and I need it parallel. So my slope parallel, remember, is going to be the same. So my slope parallel is simply 1/2, and then I have to go through that point. So that's easy enough. So that this is the y minus y1 equals mx minus x1. Okay, so remember the trick here is to change the signs on the coordinate. So this is y plus 3 equals 1/2 x minus 2. And there you have it. Ta-da! Okay, number 3, determine the equation of the line in general form that is perpendicular to that line and has an x-intercept of negative 2. Okay, I kind of tried to throw as much as I could at you on this one. So there's a couple of things that we have to know. We need perpendicular to this line. Well, in order to be perpendicular to that line, I need to know the slope of this line. So to do that, we need it in y equals mx plus b form. Okay, easy enough. So we just move the x and the 10 over. So 2y equals negative 5x plus 10. Divide by 2. Then y equals negative 5 halves x. I don't even need to figure this part out, but I'm a math guy and kind of like figuring stuff out. So anyways, that's that. And then of course the slope is this. So that's the slope of that particular line. Now remember, I don't want the slope of this particular line. I want the perpendicular slope. So watch what I do over here. I write m with the upside down t. That means perpendicular. Okay, so this perpendicular slope is going to be the fraction flipped, okay, and the sign changed. So it's going to be positive 2 over 5. So that's my slope. Okay, so now remember, you need slope and a point. Well, that's the right slope now, but it has to go through this. Remember, an x-intercept means the y is 0, so that is that coordinate. Now we can do this like y equals mx plus b. Okay, the y is 0, the m is 2/5, the x is negative 2 plus b. See how I substituted all in one step? You're totally welcome to do that. Okay, so this is going to be 0 equals negative 4/5 plus b, so that just scoots over, and b equals positive 4 over 5. So then we get y equals 2/5 x plus 4/5. So there's the equation. Oh, but wait a sec, we want general form. Oh, crazy. General form can't have fractions. So 5 and 5, the lowest common multiple is 5. Wow, imagine that. So 5, 5, 5. Okay, so we get 5y equals 2x plus 4. Right, the 5s just cancel here and here. Okay, and then we want general form, so we're moving everything over. I like to have the positive x, so we just move that guy. So you get 2x minus 5y, crazy, minus 5y plus 4 equals 0. So that is your general form. Thanks, guys. That is the end of this part.